Good morning, sir.
Good morning, sir.
Good morning.
Good morning to
Good
all.
morning, sir.
Good morning, sir.
Good morning, sir.
Good morning.
So by Sunday, I'm guessing we'll be able to like finish the homework that you have assigned us.
Good.
No, sir.
Maybe
नहीं
it's
हो-
tomorrow.
सर नहीं है
सर नहीं
सर
होगा
नहीं होगा
So check other people also if they have.
सर
सर
HCV
हो गया
पेंडिंग
सर हो गया मतलब
हो जाएगा.
हो जाएगा.
सर वेडनेसडे को ले मंडे या
So it's like
वेडनेसडे मंडे
80%
चलेगा
हो ही गया.
आपके बैच में कहाँ तक हुआ है?
सर आप होमवर्क पूछ रहे हो कि क्या पूछ रहे हो
नहीं, जो कंटेंट
अच्छा।
कवर किया है मैंने वो कहाँ तक हुआ है?
The ball falls on a wedge. Direction of rebound is not known.
Okay, we were dealing with impulses and problems on impulses, right?
यस सर
अब सुनो. Today I have few more problems from the booklet to be done as far as impulses is concerned.
ओके सर
Pretty long problems which you will not be able to do it on your own. Right? So tomorrow's class I'll deal with variable mass.
ओके सर थैंक यू
Okay, sir.
So you have time to complete your homework. But
Yes,
sir.
कहाँ तक दिया है मैंने?
सर
Exercise
एक्सरसाइज
three,
assignment के objectives are booklet till exercise 3 and HCV full except for that variable mass problem.
Right. Tomorrow's class I'll deal with variable mass.
ओके
Variable
सर
mass is a complicated situation. आराम से सीखना है. We'll do it fully. So you have time. Don't worry.
थैंक यू सर
Sir,
Thank you, sir.
And you people were asking for a practice test. It will
yes,
be
sir,
sir.
please.
Next week.
सर नेक्स्ट वीक
today is Saturday. Actually Saturday means next Saturday ही होगा ना यार. आज थोड़ी होगा.
हाँ सर सॉरी
So can you explain this concept that when there's collision, there's some interchange between kinetic energy and potential energy?
Interchange.
Kinetic energy. So, like, for example, I'll read out the question. A ball moving translationally collides elastically with another stationary identical ball. At the moment of impact, the angle between the straight lines passing through the centers of the ball and the direction of the initial motion is equal to theta. Assuming the balls to be smooth, find the fraction of kinetic energy of the striking ball that is stored as the deformation potential energy at the moment of maximum deformation.
Okay, x square. Suppose this body is moving. I'll explain this for head-on collision. You'll be able to apply it for any body. This is moving with a velocity v. This is at rest. When they collide, at the point of maximum compression, both will be moving with the same velocity. This is m1, m2, m1, m2. So initial velocity is u. What is the initial kinetic energy? Half m1 u square. At this instant, kinetic energy half m1 plus m2 v common square. V common कैसे calculate करोगे यार? Momentum conserve करोगे?
Yes, sir, that and work energy.
The difference is the loss in kinetic energy, which goes into elastic potential energy. अगर ये oblique collision हुआ, तो क्या करोगे आप? Now this will have u sin theta. This is theta. U sin theta will remain as it is. But u cos theta will become initially what was u cos theta will finally become v cos. So now what is the new kinetic energy? Half m1 m2 v common whole square plus half m1 u sin theta whole square. U sin theta is not lost.
Okay, sir.
Kinetic energy is half m u square. Where did the difference go? Elastic potential energy of both the bodies.
Yes, sir, got it.
आई बात समझ में?
Yes, sir.
And so after the collision, the kinetic energy becomes same as the initial, right?
If it is elastic,
Yes, sir.
जो भी potential energy loss हुआ वापस अगर bodies को चला गया तो it is elastic collision and kinetic energy initial and final will be same.
Sir, in that assignment, all the questions where there's like a ball moving and a wall also moving towards the ball and they collide and you have to find the velocity after the elastic collision. Sir, उसमें ray optics का वो concept directly लगा दिया.
हाँ sir.
Of
हाँ, sir,
light
उसे
rays
आया।
का speed of image and speed of object.
चलेगा. Only thing that you'll have to remember is ball is massive. Its velocity doesn't change before and after.
Yes, sir.
Okay, sir.
Assignment ka subjective questions are tough. After today's class, you will have that also as homework. Subjective
Okay, sir.
questions will consume time. आधा एक घंटा एक problem consume कर लेना. Please give. Wholeheartedly, please give. It's only then you will learn this stuff. Right?
So we should do it in parts, right? Like 2 problems, 3 problems every day.
हाँ,
तो
that
सब
way
एक
you will
साथ
be
नहीं
safe.
होगा।
सारे problems एक दिन करने के लिए बैठोगे तो you'll become slow. एक दो problems will consume so much time that mind will become dull. एक problem करो, jump over to another topic, chemistry, maths कुछ करो, फिर बाद में 1 घंटे के बाद वापस आओ. ऐसा करो. Right. 1 second, let me open the booklet. There are 3 problems from the booklet which you have to solve.
So exercise 4, right?
Exercise 4. मुझे खोलने दो, 1 second time दो मुझे. Yeah. I will share the screen 1 second. Question number 3030. दिख रहा है?
Yes,
Yeah.
sir. 30 now.
30. The problem is slightly long, right? Have patience while solving. It's a must. I'll give you 10 minutes. I'm in no hurry. Problem is long and there is something important you will learn from that problem. You're solving the problem, right?
Yes, sir.
Please don't sit and waste your time assuming I'll solve it after 10 minutes. Please do solve. The problem is important.
So, sir, in subpart 3, loss of mechanical energy up to that instant, do we have to find it for the entire system or only for block B?
Entire system.
Okay, sir.
Shall I?
Sir, 2 minutes.
Okay, I'll wait.
Yes, sir.
Can I stop the screen share?
Yes.
Yes.
Now listen. First stage here, you have this block was B, this block was A, there is a bullet of mass C. Could you tell me the values of this? This is how much?
So 2 and 2 each.
So and
And the shell is 1 kg, 9 meters per second.
9 meter per second.
9 meter per second. You can conserve linear momentum between the collision of these two particles.
Yes,
Who
sir.
gave you
Well
the
understood.
permission? When there is an external force called gravity, I can do it because gravity is
Time
non-impulsive. In the short time interval delta t, when this collides with this,
Yes, sir.
gravity doesn't produce any appreciable change. So it will be 2 into 0 plus 1 into 9 is equal to 3 into u common. U
Yes,
common
sir.
is 3 meter per second. Now where do you stand?
U is equal.
This is 2 kg. This is 3 kg given a velocity of 3 meters per second. The moment you have given indirectly 3 meters per second velocity, the tension in the string will become zero. Do you all agree with that?
Yes, sir.
The tension becomes zero. At this instant, tension will become zero. Tension will become zero because you gave velocity for this in the upward direction.
Yes, sir.
When will the string again become taut? When this moves up by a distance of ut minus half gt square, and this moves down by the same distance of half gt square. 1 second, there's somebody at the door. I'll come back in a second. Don't make noise. Fine. Where did we stop? Have a look. Now that you gave a velocity to this, recollect you did this in Newton's laws. When will the string again become taut? When this moves by a distance and this moves by a distance which are equal, right? Ut minus half gt square is equal to half gt square. So ut is equal to gt square. T is equal to
1.5.
3 by 10. 0.3 seconds के बाद the string will become taut.
Yes, sir.
That means when will the string become taut? When this mass of 2 kg came down here and this mass is here, 3 kg. Here the velocity was 3. By the time it traveled this distance, this traveled an equal distance, hence the string became taut. Once it becomes taut, there will be an impulse called T delta T. Do you agree with that?
Yes, sir.
Yes, sir.
Now, first of all, when this mass came here, just before the string became taut, what is its velocity? Time taken for this body to come here under the influence of gravity is u by g. Can you recollect this u by g? U by g, you have projected a body with a velocity of u. After u by g time, it will reach the maximum height, right?
Yes, sir.
Yes, sir.
That means velocity here is 0. Just after the string became taut, I will say this as v common and this as v common velocity. Right? Just after the string became taut, I will say this is v and this is v. Both will have the same velocity. Why?
String constraint.
Two ends of the same string. One second. Right? Now both are two ends of the same string. They'll have the same speed in opposite direction. So this will acquire v common, this will acquire v common. Velocity just before the string became taut is 0. Why? The time taken for it to reach till here is u by g, which is the time taken to go to the maximum height.
Yes, sir.
Yes,
So
sir.
I should find out the velocity here also just before the string became taut. 0.3 seconds may initial velocity is 0. What will be the velocity acquired here? V is equal to u plus gt. U is 0 here. Here u was 0. Right? This is 10 into 0.3. This will be 3 meters per second. Just before the string became taut, it is 3 meters per second. Just after the string became taut, it is v common, which I am yet to calculate. In Newton's laws, I stopped here at 0.3 seconds. Now I am speaking about the impulsive force T delta T. Are you getting this?
Yes, sir.
Yes, sir.
Yes, sir.
Now T delta T here, upward I am taking as positive. Everything in the upward direction is positive. Everything in the downward direction is negative. T delta T is in which direction?
Upward.
Right? 3 into V common minus 3 into 0. 3 into V common is upwards. 3 into 0. This is my first equation. Agreed?
Yes, sir.
Come to the second equation here. Upward is positive, downward is negative. Right? T delta T. Downward negative. 2 into V common minus 2 into 3. Minus of minus. Minus of minus 2 into 3. So, guys, upward direction you took positive, T delta T is positive. 2 into V common is final momentum, but downward direction, hence negative. Minus initial momentum. Initial is also in the downward direction. 2 into 3, hence that is also negative. Till here,
Yes, sir.
it is clear. Step by step, we are going in a very systematic way. Every step you should remember. Now subtract both the equations. Minus, plus. This is minus of minus is plus, so it becomes minus. Right? These both will go. 0 is equal to 6 times V common. This is 0 minus 6. VC is 1 meter per second. And getting positive value implies it is in upward direction. Is that part of the board visible?
Yes.
The 5 times V. The 5
Sir, 5 VC.
5. My
The 5
bad.
VC. 5 VC.
So
5
5
is
and
VC and this is 6. So VC is equal to 6 by 5 meters per second. Now look at the beauty in it. Now it is a simple pulley outputs machine. With what is the situation? I hope this part of the board is visible.
Yes.
This is 2 kg. This is 3 kg. This has a VC of 6 by 5. This has a VC of 6 by 5. But then this has velocity VC 6 by 5 because of the impulsive force. But this mass is greater than this mass. So technically this should be decelerating in the upward direction or accelerating in the downward direction. Agreed?
Yes, sir.
Yes.
What is that acceleration equal to? 3 minus 2 divided by 3 plus 2 into g. m2 minus m1 upon m2 plus m1 into g. This will be g by 5. This is decelerating in the upward direction with g by 5. Decelerating. Initial velocity is vc. Somewhere here velocity will become 0. Right? How much time will it take to do happen for that to happen? V is equal to u plus at. Final velocity is 0. Initial velocity is 6 by 5. Acceleration is g by 5 into t. T is 6 by g. 0.6 seconds के बाद it will come to rest. This will also come to rest at the same instant, and this will from here go down, this will go up. What is the time after which it will start coming down? 0.6 plus 0.3, 0.9 seconds. One of the longest problem that I have seen in your booklet.
Impulse force पूरी gas है,
Oh.
transfer करना.
Somebody is saying something which I am unable to hear.
So can I speak?
Yeah,
Sir, I'd used a different method. It seems wrong, sir, but for some reason, in all questions that have a similar pattern like this, I'm getting the right answer, sir. I don't know if that's just by coincidence or there's something else. So can I share it?
yeah.
So initially, like I didn't care about the sign of the momentum when I was conserving it. So I assumed like initially the bullet is moving upwards with a velocity of 9 meters per second, right?
Right.
So the initial momentum is 9 into 1, that's 9 Newton seconds.
Fine.
So then after collision, I assumed block B and block A to have the same velocities and their combined mass will be 5, right? Because 2 plus 1 plus 2, so that's 5.
Okay.
So after that, I just conserved momentum. I didn't care about the sign of A that is going downwards or B that's going upwards. I just took them as normal unsigned quantities and I conserved momentum. Then I got a velocity common of 1.8 meters per second, and with that I'm able to solve every single subpart correctly for some reason.
Yes, sir.
Sir, and even in the assignment that you had sent, there was a very similar question, and if you follow the same method over there, you're getting the right answer. I don't know why I'm getting the right answer though.
What you have taken is you took the momentum of this to be the momentum of the complete system. While the velocity of this is 0 initial here.
Yes, sir.
I have seen instances where you conserve momentum this way and you get an answer, but I won't suggest. Give me one day of a time. Let me solve using your procedure and find a fault in it. I'll tell you what is wrong. As it is, I'm unable to find a fault in it. But for sure, that should not give you the correct answer. I should be able to explain why that's giving the correct answer. Right? See, if you are taking the momentum of the system when the bullet strikes this, इसका velocity 0 है, मगर आप इसका velocity same as that of this wave.
Yes, I know that, but it's not
That
making
which for
sense.
sure is wrong. But then $1,000,000 question is, why are you getting the answer? There should be some reason for it. I understood what you are doing. Give me some time, evening when I'm free, I'll just put it on paper. I'll be able to tell you what mistake is happening there. That means there are 2 mistakes which are being committed because of which we are getting the answer. right? Or there should be some valid point because of which we are getting the answer. I'll see and I'll tell you.
Yes, sir. Because in every sum it's working for some reason.
Yeah, but let's play it safe. Don't take risk. As on take this down. Step by step, we'll be very clear about what's happening in this case. But your procedure gives the answer implies either it is a shortcut or we are committing two mistakes. One of them will happen. It's a shortcut for a valid reason, which we should know.
So two mistakes that are cancelling each other out, right?
We don't know. Let me search for it. Let me search. If I solve it using the procedure, I'll be able to tell. Or maybe there is a valid point which makes it a wonderful shortcut. हो भी सकता है. Because all the shortcuts that we have dealt till now were given birth to in the class only. Some student comes up with a weird idea, he'll say, why is this wrong? When we try to verify, we realize that that turns out to be a shortcut.
सर अच्छा हो जाएगा सर, फिर एक पूरे बोर्ड का क्वेश्चन एक लाइन में सॉल्व हो जाएगा.
हाँ, actually, if that is working out, then becomes a shortcut for us. In Newton's laws, the tension formula shortcut which we told you, याद है?
Yes, sir.
Yes, sir.
Shortcut actually, way back in 2008 in one of the Olympiads, they asked you infinite series pulleys. Infinite series का पुलिस पूछे. जब वो डाउट बच्चों ने लाया तो when we solved we realized that it is following a pattern. So from that pattern that shortcut was given birth to. Tell me when you people are done with it.
Yes.
No, sir.
Done, sir.
Now the second part he is asking, what is the maximum height to which it goes? This 3 kg mass, from here, it reaches till this height. That means from here till this height. आप ये height calculate करो, similarly this distance calculate करो. And third part is asking loss of mechanical energy. 2 kg mass came down by this height. 3 kg mass went up by this height. Difference mgh, this mgh minus this. So loss पूछ रहा है. Net loss. Right? This is the loss minus the gain. So I'll get the net loss. And here kinetic energy of both are zero. This is zero, this is zero. So loss is only gravitational potential energy. Is that clear to all?
Yes.
सर इसका रिकॉर्डिंग ऑलरेडी है ना फ्लैगशिप वालों का?
Yeah. Already.
Sir, do you have any info regarding whether this Sunday classes is now going to be permanent or only?
No, they'll not be permanent. Just
Okay, sir.
marginal adjustment. I will rub the board, it will take time. By then you will be solving the next question. This is called a super ball. There is a specific reason why we solve this. Are you able to see the screen?
Yes, sir.
Question number 28. Question number 28.
So,
Uh,
so just confirming by when they say assume collisions with the superball are elastic, that means even superball and floor is elastic, right?
yes, all collisions with the floor are elastic.
Okay, so
All collisions of the superball are elastic.
something really special, something that has kept me awake. A lot of things keep me awake in physics, and not only in physics.
So you have to see.
But this is very special. This is very special. I have here a basketball. Not completely elastic, but not bad. A tennis ball, not completely elastic, but not bad. Now I'm going to drop them together, vertically down, and then this ball will bounce up somehow. And so the question that I have for you is, do you think if I drop it from this height, that this tennis ball will sort of come up at most to this height, or do you think it will be lower, or do you think it will be higher? So use your intuition. In the worst case, it can be wrong. He is already pushing his finger up. So what do you think? Will the tennis ball reach about the same height? Who is in favor of that? Who is in favor of higher? Wow. Who is in favor of a lot higher? Okay. Okay, I'll try it. Now, I cannot guarantee you that this ball will go straight up after the impact, because clearly that's impossible. That has zero chance, so it'll probably go off at some direction. But you will see the effect that I had in mind. So there we go. And you see that indeed, that tennis ball goes way higher. I'll try it once more to see whether I can get it go up a little bit more vertically, but that is very difficult. It goes way higher. And this is something that you should be able to calculate. And you can, and you will. Believe me, it's part of assignment number 6. You haven't seen it yet. There we go. Oh boy, that was better. Well, do any one of you know approximately how much higher it goes? If this ball has a way higher mass than this one, of course the mass ratio comes into it. Any idea? Twice as high? You'll be surprised when you do assignment 6. It's much higher. Okay, in fact you could.
सर हम लोग कॉलेज लेवल फिजिक्स कर रहे हैं क्या अभी?
Yourself, your dormitory.
Yes.
Now I want to discuss the remaining.
He tells you that you will be calculating an assignment,
6.
right? It's just that you're solving it in exercise 4, not assignment 6.
फिरंगी एसीपी सर.
Now you should be able to calculate the height to which it goes. That is this problem. This is the standard from the MIT courseware. This question is a standard. Generally, it is deceptive. You will feel smaller will come to the same height. Why will it go to a much greater height? It actually goes, which you will calculate. And then waiting.
तो आंसर चेक कर सकते हो.
You have typed the answer or you want me to see the answer?
Sir, I've typed the answer and the
Right.
एक minute.
Yeah, no hurry. I'll wait. Nine H is correct. Please apply the approximation. Capital M is much greater than small m. Don't give me the answer in terms of small m and capital M. 9H is correct.
So it will be 9h plus the diameter of the super ball, na? Above the ground.
That is okay. Diameter of the super ball will be small when compared to 9 times the height.
Okay, sir.
Nine H is correct. Shall I? I'll stop the screen share.
Yes, sir.
Now, here what happens is problem's main significance is this is coming down with under root 2gh. This already collided with the ground and it is rising up with under root 2gh. Why is it rising up with under root 2gh? You told me it is a perfectly elastic collision. If it strikes with a velocity of under root 2gh, it will rise up with a velocity of under root 2gh. Somebody down the lane has given me permission to conserve momentum between the two, despite the fact that there is gravity acting in the direction. Gravity is
Non-impulsive.
so I am given the permission to conserve momentum in that short time interval. If the time interval is long, I do not have the permission to conserve momentum. Am I very clear in that aspect?
Yes, sir.
In that short time interval, I take everything in the upward direction positive, downward direction negative. Always when you are solving these problems, the only mistake you will tend to commit in 99% of the cases is positive and negatives. So please write clearly this way. Right? Initial momentum, capital M into under root 2gh. Final momentum, I will take this as V1 and this as V2. Minus small m into under root 2gh is equal to capital M into V2 plus small m into V1. Conservation of linear momentum between the two. This is my first equation. This is minus because it is in the downward direction. I have taken downward direction as negative. Right? What will small e be equal to? V2 minus V1 upon U1 minus U. What is V2 velocity of capital M? It is in the upward direction. Minus V1 that is also in the upward direction. U1 is under root 2gh. U1 is under root 2gh but in the downward direction minus under root 2gh. V2, I mean U2 is in the upward direction. So I keep it as positive. This is V2 minus V1 minus of 2 times under root 2 GH. E is equal to 1. So your equation will be V2 minus V1 is minus of 2 times under root 2 GH. This is my second equation. This is my first equation. Take 2GH common, it will become capital M minus small m. Remaining simplification, I believe I can bank on you people. Last step, don't forget to put small m is much lesser than capital M.
Yeah. So, इसमें like you had said, light particles always undergo elastic collisions, whatever the situation is.
Light particle, yeah.
Photons, sir. Sorry.
Photons, okay.
So over here you can imagine this capital M mass to be like a mirror and the small m mass to be like a photon, and both are moving in opposite directions. Then we have learned the formula in ray optics. So you can directly do that. You won't even have to do this like this simplification.
Okay, you want to take capital M to be a fixed surface because it is
So capital M is like a mirror that's moving upwards with root 2 GH velocity, and M is like the light ray that's moving downwards with a light ray or an object moving downwards with root 2
perfectly
GH.
okay, no issue with that. Perfectly okay. Capital M is a mirror moving with under root 2 GH. And then the last step we put capital M much bigger than this point. Yeah, no issue.
Yeah, so.
Can I proceed?
Yes. Sorry.
Question number 36. Question number 36. Are you able to see the question?
Yes.
Sir, can you solve this one?
Can I stop the screen share?
Yes, sir. Yes.
Now listen. This problem is no doubt lengthy, slightly difficult to visualize. This is M1, this is M2, this is the initial state of M3, given a velocity of how much? We know.
V0.
Final state means when will M1 eventually start moving? When M3 comes to this particular point, when the string becomes taut. When I give a velocity V0 here, this is a horizontal table, and on a smooth surface, we have given a velocity. When this mass comes to this end and the string becomes taut, there will be an impulse J on this, J on this. I will write J dash here, which I will not use. I will write when there is J impulse on this, there will be J dash impulse on it. This is A, this is B, this is C. This acquires a velocity of V1. Then this will also acquire a velocity of V1 because both these endpoints are two ends of a string. They should have the same velocity. Right? Now, why should I take 3m, 2m? Let me not introduce new variables. We already have sufficient number of variables. So far,
how did
so
you-
good.
So
Right?
how did you determine V1 will be parallel to V0?
V1 is parallel to
V0.
V0 से कुछ लेना देना है ही नहीं. J dash के डायरेक्शन में V1 लिया ही नहीं. J dash is the only force on it. T delta T. This tension into delta T is the only impulse. So I took V1 in that direction. I got nothing to do with this V. Right? Say something.
Yes, sir.
So now these both will have the same velocity along the length of the string. I take this to be V2, I take this to be V3. Taking all three masses as one system in the horizontal direction, can I conserve linear momentum?
Yes.
Yes, sir.
Yes, sir.
Taking all three masses as one system in the horizontal direction, what is the initial momentum? 3m into V0. What is the final momentum? M into V1 plus 2m into V1 plus 3m into V3. M and M. 3V0 is 3V1 plus 3V3 is my first equation. Conservation of linear momentum in the horizontal direction. Taking all three masses as one system, there is no external force on them. Now the question is, can I conserve linear momentum along the y-axis as well? You can. 0 is the initial momentum in the y-axis. Final momentum 2m into minus v2 plus 3m into, I will call this vy. 3m into vy. So vy is 2v2 by 3. Vy is 2v2 by 3. I will not take this as the second equation. I already incorporated this vy in terms of v. So I will take this velocity as 2v2 by 3. So I have already incorporated that. I will not count that as second equation. So vy is not a variable for me. Vy is not a variable. I eliminated that variable. Agreed?
Yes. Yes.
I have conserved linear momentum along x-axis, along y-axis, taking all three particles as one system. Now I have more variables and I have less number of equations. I will have to think of alternatives. One alternative that will strike to my mind whenever I see a string is length of the string should remain
Constant.
smart. Now have a look at it. This angle is 30 degree. This angle will be 30. This angle is 30 degree. Yes or no?
Yes.
Yes, sir.
Yes.
Now, V2 when I resolve along this string, it will be minus V2 cos 30. This angle is 60 minus V1 cos 60. Both the velocities are resolved along the length of the string. Both are approaching the center. I put a negative sign to both of them. Constraints for this kind of the string. Are you convinced?
Yes, sir.
Yes, sir.
Come to this. Vy along this direction. Vy I will not carry because I eliminated the variable. 2v2 by 3 cos 30 minus 2v2 by 3 cos 30. Why? That is also towards the center of the segment. V3, this angle is 60 degrees, moving away from the center of the segment. V3 cos 60, sum total is 0. This is my second equation. You should be completely convinced of this.
So can you explain again how you got Vy is equal to 2v2 by 3?
Conservation of linear momentum in the y direction. इसका तो कुछ है नहीं. Initial momentum is 0. 2m into v2 is 3m into vy.
Okay, so understood.
So that vy when I resolve in this direction, 2v2 by 3 cos 30. v3 when I resolve in this direction, v3 cos 6. This is my second equation. This should be a second equation. No, yeah, you already used it up. Right? Vy is not a variable anymore for me. How many variables do you have? V1 I have, V2 I have, V3 I have. So I need one more equation. Impulse को लाना ही पड़ेगा. Have a look at this J. This J. This J in this direction will be how much? J cos 60. I'll take everything in this direction positive, in this direction negative. Minus J cos 60 is equal to 3m into V3 final momentum minus 3m into V0 initial momentum. Till here, I had three variables and two equations. What are the three variables? V1, V2, V3. And I have only two equations. So I am forced to introduce the impulse equation, but the risk that I am taking is I have introduced a new variable also along with it. J now came into your life. J cos 60 with a negative sign because it is towards this direction. 3m V3 minus 3m V0. Now, in a helpless state, you introduced J. Please eliminate J. My problem is solved. How do I eliminate J? J cos 30 is equal to 3m into Vy 2v2 by 3. This is my fourth equation. How many variables do you have? V1, V2, V3 and J. Four equations, four variables. I'm damn sure each one of you know the value of cos 30 and cos 60. Somebody who has a doubt with cos 30 and cos 60, raise your hands. I'll get them. Wonderful.
First, they will give bitcoins with that hand, sir, then you chop it.
सही बात. पहले bitcoins need to be collected, then we can chop them up.
Sir, so in this question, sir, can we take like the two balls in one cases and the next two balls in the second case?
not really feasible. There will be an external force. अब सुनिए, in this aspect, I'm reminded of something else. Let me clear the doubt first. No, some students ask me, you took only J. Obviously,
But J
I
dash
took
also
impulse
there.
on 3M. If I take impulse on 2M, this J, why didn't you take? I'll not. Because if I do that, impulse on 2M अगर touch भी किया ना, मुझे फिर एक और variable J dash will walk into my life. एक और variable आ गया, तो then you'll again have to put J dash. Not that it is impossible. If I took impulse on 3M, both the equations are impulse on 3M. क्यों भाई साहब 2M क्यों अवॉइड किया आपने? 2M पर अगर impulse ले लिया, तो J dash walks into my life. To eliminate J dash, I need one more equation. ऐसा नहीं कि नहीं है मेरा पास, है. J dash is M into V1. But why will I increase one variable and increase two more equations and so on? So I preferred this and not 2M. How did you know that you had to take the impulse on 3M? Common sense. If I take 2M, J dash also walks into my life. If I take 3M, only J walked into my life. One variable is more than sufficient for creating headache for me.
So,
Hmm.
at the impulse, ball B will have only velocity along x, like horizontal or both the directions.
Why, sir? This J will have a horizontal and vertical component. So I'll have V1 and V2. J has both that. This J cos 30 को क्यों neglect कर दूं?
Okay, sir.
So here the net velocity of 2M will not be along the string, na? Connecting it to 3M.
Velocity will be along the string. It will be along the string. Resultant of these two. There is a brief. See there. No, there is another horizontal. Net velocity.
Yes, sir.
There are two impulses. Resultant of these two के direction में 2M will have velocity. Impulse is nothing but force in a short time. So resultant of that force will decide the direction of acceleration.
Sir. The net velocity of ball B will not be determined only by string BC, right?
Right. J dash also will come into picture.
So,
If somebody is keen on writing or asking me the value of J dash, then what will I do? This is J cos 60. J cos 60 minus J dash is 2m into V1. Right? J cos 30 is 2m into V2. And then what is J dash? J dash is equal to m into V1. Solve these three. You get V2, you get V1, you can get J dash as well. अगर उसने पूछा J dash क्या है, that part of the board visible है कि नहीं?
Yes, sir.
If somebody is keen on calculating V2, actually here V2 आ जाए. Somebody is keen on calculating resultant of this V2, V1. Get V1 from this. How will you get V1? J dash is m V1. So substitute the J dash here. I will get V1. Once I get V1, I know V2 resultant can be calculated for 2n.
Yes, sir.
so in equation 3, it won't be plus 3 and B0.
Equation 3.
Plus 3 and B0. Or so just confused.
Final minus initial momentum.
Okay.
It is plus only, but the minus comes because of final minus initial.
Okay.
The exercise 2 and exercise 3 were quite relaxing as compared to exercise 1.
Yes, sir.
Exercise 4 will be troubling you again. Homework. Exercise 4 up to the first 39 problems.
सर उसके बाद सब कुछ ना
उसके बाद 40th question से it's variable mass, which I'll be covering in tomorrow's class. 40th question say the chain falling is a variable mass problem. Right? So up to 39th question of exercise 4. सुनाई दे रहा है सबको?
Yes, sir.
39th question of exercise 4 तक all problems of exercise 4 you will be able to solve. Right?
Yes.
Now between you and me, let us have a very frank discussion. How much time do you need to complete this homework? Tomorrow I'll deal with variable mass. That will theoretically complete conservation of momentum. Your homework will be after tomorrow's class, complete HCV, assignment and booklet. पहले बीच में कोई डाउट लेक्चर हुआ है आपका? Is HCV covered or not?
No, sir. Exercise 1 is covered.
Okay. HCV I have to discuss. Assignment 2, 3 I will keep it pending for the doubt lecture so that booklet ka assignment they'll be able to clear. So HCV, sorry, booklet ka 2 and 3 exercises I'll keep it pending. Doubt lecture mein clear karwa. HCV and assignment I'll discuss in the class. Next week also we may have 2 lectures at least. I'll convert both the lectures into doubt lectures so that I am buying time for you people. If not, I'll have to start. It's a very deadly chapter. Rotation
Actually, up to
right? So next week, both the lectures they'll convert into doubt lectures. If you don't catch up with your homework, you're in soup.
Sir, rotation can we start after the MT, if possible?
MT तक क्या? MT is the last day of January.
28, 29.
सर पहले स्टार्ट कर दो सर, like we as long as we don't get homework in that initial little bit, वो चल जाएगा.
हाँ,
Sir,
homework
आपने
नहीं
बोला
मिलेगा.
2-3 lakhs.
Sir,
Sir?
you had told us
That can
that
be adjusted. Homework MT के बाद ही मिलेगा.
Okay.
सर आपको ऐसे बोला.
Listen. I'm not sure about it. अगर assignment discussion takes time, assignment का subjective questions will take time. For example, if you people observe today, we have solved only 3 problems. Right? When these subjective questions are huge, it takes time. But today you have attempted them in the class. Those assignment, I expect you to attempt and come. I'll directly discuss. So I actually don't know how much time it will take for the assignment to be discussed. और HCV जल्दी हो जाएगा, इतना दिक्कत है नहीं. Booklet you will be doing it in the doubt lecture. So out of the 2 lectures, I am assuming that I can complete in 2 lectures both HCV and assignment. This is my assumption. How far right, how far wrong, we don't know. Right? So maybe if that next week we consume even 1 lecture, we are close to the major test. Then before the major test, last 2-3 days, he'll give you a gap. So that way, no, we have 3 more weeks now, yaar.
2 weeks.
2 weeks. If we are discussing these doubts, if I am left with only 1 lecture, I'll just revise few good problems from conservation of momentum. If I get only 1 lecture that next week before the major test, so then I'll revise few problems from conservation of momentum.
Sir,
That
you
will
had
help. Don't worry.
Sir, you had asked us to pray that offline classes start before rotational dynamics.
Actually, I wish that would have happened, but destiny.
सर आपको बोलना चाहिए था कि रोटेशनल बहुत इजी है, तो फिर हम लोग भी ऐसे मन में ये बैठ के चलेंगे कि इजी चैप्टर है.
No. It is better be informed. See, I'm standing here. Something pops up in front of me all of a sudden, I get frightened. But the same type of adrenal rush I don't have when I'm going for a boogie jump, right? There you are mentally prepared. You enjoy that adrenal rush. You are going on what you call
Roller coaster.
Imagika gaye ho?
Yes, sir.
When you know that you are going through a huge overhaul of change in acceleration, you'll be mentally prepared. You'll enjoy.
नहीं सर, फटती तभी भी है सर.
Anyway, fine. So see you people in tomorrow's class. Good day.
Bye, sir.
Yes,
Hi,
sir.
sir.
Thank you, sir.
Rotational